Here's integrated 3. This is problem 10-165. It says the Spirit Club recently got a call from the school executive council asking them to make a committee. They now have 10 volunteers and will need to choose a 3-person committee. They need to calculate the combination of 10 things taken 3 at a time, the number of possible committees, but they have no calculator with them. Al had a thought. I remember that the number of 3-person committees you can select from 9 volunteers is 84. This would be the number of committees the 10th volunteer will not be on because he or she would be selected from the other 9 members. How would you calculate this number? So if there's 9 volunteers and it's still a 3-person committee, it's going to be a combination of 9 things taken 3 at a time. And he already told you it was 84, so maybe you didn't need to calculate that. I can't help it, though. I would calculate that very easily using fraction math because I love fraction math. So I would have gone 9 factorial because n is 9 and r is 3. So I'd go 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 9 factorial. And then down here, I would go 9 minus 3 factorial. Well, 9 minus 3 is 6. So that's 6 times 5 times 4 times 3 times 2 times 1. See how these cancel out? Oh, oops. I shouldn't have hit the 7. Sorry. The 7's still there. And then this is r factorial. That's 3 times 2 times 1. Well, the 3 cancels with the 9. And leaves a 3, and the 2 cancels with the 8 and leaves a 4, so I got 3 times 4 is 12, and 12 times 7 is 84. So it's easy to do it with fraction math. So anyway, that was letter A. Letter B says, I also know how many committees the new volunteer will be on because I can just add his name to each of the 2-member committees I had already selected from 9. So again, we're talking about he already knows the answer to 9 things taken 2 at a time. So how many possible committees would include the 10th volunteer? That would be 9 things taken 2 at a time. And again, I mean, he already told you, I think, did they say it was 36? No, they didn't. So maybe you would just do that this way. So n factorial, n minus r factorial, and r factorial using this formula right here. So n factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 9 minus 2 is 7 factorial, which is 7 times this part right here. And then r factorial, that's 2 factorial. So all this whole thing with the 7s, it all cancels out. You don't need a calculator for this. And then 2 times 1 is 2, and then if you divide the 8 by the 2, that's why I got the 4 there. 9 times 4 is 36. Okay, so that's letter B. And so letter C, without using a calculator and without multiplying or dividing, explain how Al used parts A and part B to calculate the combination of 10 things taken 3 at a time. So I don't know if you would just come up with this in your mind, but I think the book wanted you to notice that for A and B, those are 9 things. 9 things taken 3 at a time, or 9 things taken 2 at a time. And if you remember your Pascal's triangle, you might remember that the row of 9s, or the row like this would be something raised to the 9th power. Anyway, this row, you add, like if I want to get the 10, I add the 1 plus the 9 and it gets the 10. If I want to get the 45, I'd go 9 plus 36 is 45. That's how this table, this Pascal's triangle works. 36 plus 84, that gives me 120. So if I knew the combination of 9 things taken 2 at a time, and the combination of 9 things taken 3 at a time, well, that gives me the combination of, see how I'm in the 10th row now? And I'm 1, 2, 3. This is the combination of 10 things taken 3 at a time. So I'll just let you read the official answer. You could have added the combination of 9 things taken 3 at a time from answer A, and then added that to the combination of 9 things taken 2 at a time. So basically you can go 84 plus 36. I think that gives you 120. How's it related to Pascal's triangle? It says the 10th row entry of Pascal's triangle is the sum of the 2 9th row entries above it, and these numbers correspond to the total number of combinations when one more choice is added. So basically, I'll show you how the combination of 10 things taken 3 at a time, it equals 120, and that's because I did 10 factorial on the top, and then I did 10 minus 3, which is 7 factorial, times 3 factorial. Well, this whole part with the 7s, that all canceled out. The 3 times 2 times 1, I think I canceled my 3 out with my 9 and my 2 out with my 8. And I had, well, 3 times 4 is 12 times 10, that's 120. Okay, so I got 120. So that clearly you can see combination of 9 things taken 2 at a time plus the combination of 9 things taken 3 at a time. When you add those together, you get 120. That's how and 120 is a combination of 10 things taken 1, 2, 3 at a time. So it was kind of actually there's an X through it because I think it's a little bit of a confusing problem, but thank you for asking.